लाइक, शेयर, सब्सक्राइब ये इस चैनल के 3 स्तंभ हैं। इन्हें दबाइए और आगे की वीडियो को एंजॉय करें।
Namaste and welcome back. So in the previous video of linear regression, we have seen that we express the function f as an linear function in x. So we have a related slope term, we have a related intercept term. In this video, we are going to see that how do we actually calculate them? How do we estimate the coefficients of linear regression? We have data, we have some of the observations like 200, 300 observations, we have x, we have y. Now from these data, how do we estimate the variables or the model coefficient such that we have the best fit line, we get the best fit line? So what restrictions are included, how do we calculate, what is the procedure, that would be told in this video. So I think let's start. Let us first set up the problem and then we will try to solve and calculate the coefficients in a linear regression. So let's set up the problem first. We have n observations, that means x1, y1, x2, y2 and up to xn, yn. We have n pairs of information and we are trying to find a model, a linear model such that y cap is equal to beta naught cap plus beta 1 cap into x. So we have y, we have n observations of y and we have n observations of x, and we have to find beta naught and beta 1 cap. Now the question arises that we have to find these coefficients, but we need some restrictions on how we can find the beta naught and beta 1 cap. So let us first define the problem. What is the problem is? So the problem is we have to estimate beta naught cap and beta 1 cap such that, now this such that is our restrictions and will help us to estimate beta naught and beta 1 cap, and this restriction is such that the residual sum error is minimized, or the sum of residual error, residual sum error, residual error sum, okay, all are the one thing which is minimized. So this is a key term here, that residual sum error. So let us first see that what is the sum of residual error, that is RSS. So RSS is defined by summation of yi, that is the actual observation, minus yi cap, that is the predicted observation, whole square, I is equal to 1 to n. So this is the squared sum of residual error, and yi minus y cap I is the residual error. We take a square and we sum it. Now we have to find beta naught and beta 1 such that this term is minimized. Okay, so this is our problem. Okay, this is the setup. Now let us try to solve the problem. So just calling it as S, the RSS as S, and putting the values of y cap, because I have estimated y cap as this equation. So it is y I, of course yi, minus beta naught minus beta 1 cap into xi whole square. So I have found S with respect to beta naught and beta 1, and I know yi from here, I know xi from here, so all the terms in this equation is known. Now I can go for optimization, that is the minimization of this term. Now simple calculus tell us that if we want to minimize any function, what we do, we take a derivative of that and we put it to 0. So we have to minimize S with respect to beta naught and beta 1. So what we will do, we will find the derivative of S with respect to beta naught and we will put it to 0, and we will find the derivative of S with respect to beta 1 and put it to 0. After solving these equations, we should get our beta naught and beta 1. Let's see that we are getting or not. So the first term, let us try to solve. Del S by del beta naught. We will differentiate this term with respect to beta naught. So del S by del beta naught becomes summation. Of course this 2 will come here, and we have the bracketed term, that is yi minus beta naught cap minus beta 1 cap into x Now after that, the square term is differentiated. We have to differentiate this term with respect to beta naught, and the answer would be -1. Why -1? Because of the assumptions involved in linear regression, that these the coefficients are independent, and the beta naught does not depend on x, does not depend on y. So I'll take a -1 here and put it to 0. What I have done nothing special. It's very easy. I have just differentiated this term, this square term, that is a differentiation of x square is 2 times x, into this x term is differentiated with beta naught, nothing else. Similarly, del s by del beta 1, let us try to differentiate this. So it would be 2 into yi minus beta naught cap minus beta 1 cap into x. Now I have to multiply the coefficient of beta 1 cap, that is minus xi equal to 0. So what I see, that I have obtained two equations and I have two unknown, that is beta naught and beta 1 cap. So I should get some solution, some unique solution. So let us solve these equations. Okay, so the first equation, if I try to solve is, so 0 is equal to, I think the 2 and the -1 term can cancel with 0, so I have yi summation, okay, minus beta naught cap into n. Now how n appear here? N is the number of observation. Beta naught is a constant for all of the observation. Summation beta naught, this summation is from I equal to 1 to n. The constant comes out and we have 1 only in the summation term, and we have added 1 n times. Okay, so this is how beta n appear here. Similarly, we will try beta 1 cap into xi summation equal to 0. This is my first equation. Secondly, if it is 0, that terms would be yi into xi summation, xi into yi minus beta naught summation xi, because xi get multiplied here, and we have minus beta 1 cap summation xi square equal to 0. So we have two equations, two unknowns, and you can see that both the equations have variable beta naught and beta 1. Okay, so these are two simple linear equations. It can be solved here. So I am giving you task that if these are the two equations, please solve these equations and get your own result and compared with you can search online, or I'll provide you the solutions. But after getting to these two equations, it is very easy to determine what is beta naught and what is beta 1. Okay, so this was all about estimating the coefficients of linear regression, how it's done, and the most important part is that how we have explained the problem, how we have mentioned the problem. Problem is estimate beta naught and beta 1, that are the parameters of linear regression, but with a constraint that sum of residual errors, squared sum of residual errors must be minimized.